Hey everybody, in this video we're going to be solving differential equations to get general solutions. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. So here we've got these differential equations. Now, unlike the other video that you may have seen with differential equations, all of these are going to be written with dy dx. And that's on purpose. The reason for that is we need to have these two terms because I always tell people that there's three steps. The first step is you separate. And by separate, I mean everything with y on one side, everything with x on the other side. So for step one, we're going to multiply dx to the other side. So dy equals 3x squared dx. So everything with y over here, everything with x over here. That's step one. Second step is we integrate. So integral of dy equals the integral of 3x squared dx. And then we have the integral of dy is y. The integral of 3x squared is x cubed plus c. So we integrate. And then finally we isolate. Now here we don't have to worry about step 3. Why? Because y is already by itself. So this equation is a general solution for this differential equation. It's a general solution because we have this plus c involved. We don't know what c is. It could be anything because we don't know any more information about what it ought to be. When you are given a specific point that the function should go through, then that becomes a particular solution. But here for this video, we're going to have them all be general solutions. So on to the next one. We have dy dx equals y over 5. So first step is we're going to separate. So if I multiply both sides by dx, I get dy equals y over 5 dx. But I'm not yet separated because I have a y here and a y here. So I need to divide y over to the other side. So I have 1 over y dy equals 1/5 dx. So there, now that is separated. That's step one. So the second step is we integrate. So integral of 1 over y dy equals the integral of 1/5 dx. So we get ln of absolute value of y equals 1/5 x plus c. So now we've integrated, but now we need to isolate. Here we have to go to step 3 because we have to get y by itself. So we have ln of y equals 1/5 x plus c. And to get rid of the ln, we raise e to both sides. So y equals e to the 1/5 x plus c. Now what you will often see is books separate this out and write it as e to the 1/5 x times e to the c. Now again, c is an unknown constant, so if I raise e to some unknown constant, that's also an unknown constant. So oftentimes you will see different teachers and books write it like this. We just take e to the c and just write it as its own unknown constant, like that. All right, for number 3, here we want to first separate, multiply the dx over. So dy equals y squared dx, and the y squared has to be divided over to the other side. So we have 1 over y squared dy equals dx. Now since we're going to be integrating, I'm going to rewrite this as y to the negative 2 dy equals dx. So now we integrate. So integrate y to the negative 2 dy equals the integral of dx. So this is going to become negative y to the negative 1 equals x plus c. And I'll write this as negative 1 over y equals x plus c. So we need to get y by itself. So to do that, I'm going to first take my equation, negative 1 over y equals x plus c, and I'm going to multiply both sides by y. So x plus c times y, and then I'll divide both sides by x plus c. And that will give me y by itself. So that is the general solution for this differential equation. on to number 4. So for this one, to separate, I multiply by dx. So dy equals xy dx. And then we divide by y. So 1 over y dy equals x dx. So now we've separated. So now I can integrate. So we have 1 over y dy equals integral of x dx. So on the left, this becomes ln of y. And on the right, we have 1/2 x squared plus c. So now we have to isolate y. So I take ln of absolute value of y equals 1/2 x squared plus c, and we raise e to both sides. And so we have y equals e to the 1/2 x squared plus c. And similarly, as with number 2, we can do the same thing here. We can break up this exponent, e to the 1/2 x squared times e to the c. And since this is an unknown constant, we have e to the 1/2 x squared times c. So looking at number 5, here we multiply dx over. So dy equals x cubed y squared dx. And then we divide by 1 over y. So we have 1 over y squared dy equals x cubed dx. And I can rewrite that as y to the -2 dx, or sorry, dy equals x cubed dx. So now we've got that separated. So now we can integrate. So y to the -2 dy equals integral of x cubed dx. So this is going to become negative y to the -1, and that's going to become 1/4 x cubed, x to the 4th, excuse me, plus c. And so when I rewrite that, that's going to be -1 over y equals 1/4 x to the 4th plus c. So that's step 2. I've integrated. So now for step 3, I need to isolate. So I have -1 over y equals 1/4 x to the 4th plus c. So I'm going to multiply y out. So I have quantity 1/4 x to the 4th plus c times y. And then I'm going to divide by this quantity. So I have -1 over the quantity 1/4 x to the 4th plus c. And all of that equals y. So there is our general solution for number 5. For number 6, when we multiply by dx, we get dy equal to 5y over x equal times dx. We have to divide both sides by y. So I have 1 over y dy equals 5 over x dx. So now everything is separated. So now I can integrate. So the integral of 1 over y dy equals 5 over x, the integral of 5 over x dx. So the integral here is going to be ln of y equals 5 ln of x plus c. So now I've got that integrated. So now I'll isolate. So I take ln of absolute value of y equals 5 ln of absolute value of x plus c, and I raise both sides to e. Now remember that this is a quantity. So I've got e to the 5 ln of x plus c. All of that is part of the exponent. But here's what we can do to simplify this. We can rewrite this as e to the ln of x to the 5th times e to the c. Now what happened? Two things happened here, and that is that first I separated this into this part and this part of my exponent, and I multiplied them instead. But I also brought the 5 in. That's a property of logarithms that if you have a coefficient out front, you can bring that up as an exponent inside. Now why did I do that? Well, e ln cancel out, and we're just left with x to the 5th times e to the c is just c. So we just left with cx to the 5th, which is a much simpler version for this. All right. So now, with number 7, a lot of people get confused about this one because here, when I multiply dx over, I got y plus 2 times dx. The y and the 2 are inseparable. They both have to go over together. So it's 1 over y plus 2 dy equals dx. And so this is how we separate it. And then to integrate, it's going to be integral of 1 over y plus 2 dy equals the integral of dx. So now we take the antiderivative, and that's ln of y plus 2 equals x plus c. And so that is what we get when we find this integral, but now we have to isolate. We have to get y by itself. So ln of y plus 2 equals x plus c, and we raise e to both sides. And when we do, the e and the ln cancel, so we have y plus 2 equals e to the x plus c. And as before, we'll break that up into e to the x times e to the c, which is the same as e to the x times c. And then to get y by itself, all we have to do is subtract 2. So y equals c, e to the x, I'll move the c out front, minus 2. All right, so on to the last one. Here, we multiply by dx. And so we have x e to the y dx, and then we have to divide e to the y over to the other side. So we have 1 over e to the y dy equals x dx. Now, to make this easier, when we integrate, I'm going to rewrite this as e to the negative y dy equals x dx. So there is what we get this is what we get when we separate. Now when we integrate, we have e to the negative y dy in the integral equals integral x dx. So my antiderivative here is negative e to the negative y equals 1/2 x squared plus c. So now we've integrated, so now we have to isolate. So negative e to the negative y equals 1/2 x squared plus c. So the first thing we have to do is get rid of the negative. So you have e to the negative y equals negative 1/2 x squared. Now because c is an unknown constant, multiplying it by a negative is a bit of a moot point. So I always say it's still an unknown constant, so just leave it as that. So now, to get rid of the e, we take the ln. So we have ln of both sides. ln of e to the negative y equals ln of negative 1/2 x squared plus c. These cancel, leaving negative y equals ln of negative 1/2 x squared plus c. And so finally, to get that by itself, we just multiply by negative 1. So we have negative ln of negative 1/2 x squared plus c. Now some teachers will want you to bring that negative 1 inside. And so you'd write that as negative 1/2 x squared plus c to the negative 1. And some would even go so far as to have you write that as 1 over the quantity 1/2 x squared plus c. With a negative right there. Now, I'm fine with you leaving it like that, but your teacher may want you to do it like that. So that depends on what your teacher or your assessment is asking for. Thanks so much for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher, share it with your students if you found it helpful. Or if you're a student and you found it helpful, share it with your classmates. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.